Hello and welcome to this repair tutorial, and today we're going to look at a Marantz PM6005 audio amplifier. In terms of general specifications, RMS power output, and this is a frequency range of 20 Hz to 20 kHz, you're looking at 45 watts into 2 times 8 ohm speaker load, but this will increase to 60 watts if you're connecting 4 ohm speakers. And then on the rear you have 2 sets of binding posts. And then from the front you can select speaker set A and speaker set B, or both speakers if you wish. Or if you're using maybe the headphone socket and you wish to disable the speakers, then you can deselect both sets if required. And then in terms of total harmonic distortion, you're looking at 20 Hz to 20 kHz, and the technical manual will refer to simultaneous drive of both channels with an 8 ohm load. And then that total harmonic distortion comes in at 0.08%. And then frequency response is 10 Hz to 70 kHz. And then for input sensitivity, and this is the phone input because it has a moving magnet circuit built in, you don't need an external adapter or preamplifier, and there's no plug-in module. You're looking at 2.2 millivolts with input impedance of 47 kiloohms, and that's standard. And then for the line inputs, so we're talking now about the CD tuner, network, record 1, record 2, that's up at 200 millivolts for input impedance of 20 kiloohms. And then this unit has a nice feature because you can connect an optical input or a coaxial to the rear of the amp. And overall weight is 7.6 kilograms, and then the dimensions are 105 high by 440 millimeters wide with an overall depth of 370 millimeters. Now on previous repair blogs I have expressed a liking for this amplifier, and I do. I think cosmetically, this series of amplifier, looks good, and also the design is attractive, and the overall build quality is good as well. And then the amplifier comes with a remote control, and that full remote control does all of the operation of the amp. So if you want to, for example, increase, decrease volume control, or you want to select any of the functions which would normally be by the front panel, you can do that. And as with most of these types of amplifiers, you can place the amplifier into a standby mode, and then if you wish, if you just sort of rotate the input selector, or for example you press the button on the remote control, you can quickly switch it out of standby mode then. So let's sort of talk to you about the issues with this amplifier when it came in. And actually there was two. So this is similar in a way to one of the previous repair blogs which I did more recently. This is a case where the second fault, you couldn't actually identify it until you cleared the first fault. So what I'm now showing you here is the input start board, or what we call the startup power supply. What you can see from the rear is you can see the very large toroidal transformer, and then this is mounted under a metal case, so that's a nice design for noise and also any sort of induced noise which could come in electrically, so that's a nice feature. And then you can also see there's a small EI transformer on the startup board, and then you also have a small power relay as well. And once the power relay energizes, it will then switch the power then to the toroidal transformer. Now, as with all these amplifiers of this type and sort of age, this startup transformer will provide the power to the microcontroller. I've covered this in previous blogs. So when you hit the remote, or as I said, you hit the front panel, then to get it to come out of standby mode, what should happen is after probably 3 or 4 seconds, you should hear the power relay energize, and then the transformer would receive input supply voltage, and then the necessary secondary voltages would then, after rectification, be applied to the amp. And the amplifier, because it has a microcontroller, also has quite a detailed protection circuit which will be looking for a number of different things. But part of that detection circuit, it monitors for key voltages as well. So there's common, for example, your plus or minus 15 volt supply for your pre-amplifier circuit and low voltage circuit, as well as other DC supplies. So when you power this amplifier up, what you noticed was that it appeared to come out of standby mode, and the LEDs on the front illuminated depending on what the selection was. So whatever the last input selection was, if maybe you had the loudness button had been selected, or even one set of speakers. But then after about 2 seconds you hear the power input startup relay de-energize, and then the front fascia power LED then starts to flash, indicating that it's gone into protection mode. Now there are a number of issues which could relate to that type of symptom, but not in this case. And this is kind of like an unusual fault in a way, but I think it's probably a fault which you may well see on these series of amplifiers over time, and I think it's more like of an over time type fault. So the next thing that I'm showing you is what I'm measuring here is the DC offset. So what I show is that the DC offset on the left channel gives a reading of minus 4.060 volts, and that is very high. So it's not that something has gone short circuit, because the dim bulb tester wasn't identifying anything like that. But what has happened here is that the circuit itself is being incorrectly biased for whatever reason. And what's interesting to note is that if you put the meter then and did the measurement then on the right channel, it wasn't significantly high, but it was probably around the 200 millivolt range. And you could say, okay, well, there are adjustments on the circuit board to adjust for DC offset, which we'll come to in a moment, but that's not what needed to be done. There was an underlying issue, because when you've got by minus 4 volts, that's not something that you're going to adjust with a preset on the circuit board. So the next thing that I'm now showing you is an extract from the service manual, and you can see here that this is showing the left channel, and this is both the input part of the stage, and then you have the voltage amplifier, and then the driver, and then the main output stage. And I've made a number of references here. So typically for this type of fault, because the protection circuit energizes, it's very difficult then to make voltage measurements, because you don't have anything to reference back to. Now the service manual is available, and it's quite detailed, but it's not like the older type service manuals for electronic equipment, where you would have a detailed schematic with all the different voltages on there. And whenever protection circuits operate, it depends on the nature of the fault. So I wouldn't say, go out there and then deactivate the protection signal to the microcontroller to effectively override the protection circuit. But here, the most logical thing to do was to remove the main board, and then to do what is a very common technique, is where you make a number of measurements across, comparing the defective channel or the faulty channel with the working channel. Now the nature of this fault is such that even if you do that, and what I show here is the circuit board removed from the amplifier, and this is where, as I said, you would just meter from the right channel across the component and then cross-reference them back to the left channel. Now if you do that, what you'll notice is you don't actually record any difference in resistance, none. And typically these kinds of faults could be created if maybe a resistor went high in value, or maybe a capacitor became more like a resistor than a capacitor, or even a transistor became leaky. And when I talk about leaky, that means that the junctions within the transistor are conducting when they shouldn't be, and that can be the same for a diode as well. Now when you look here at the circuit diagram again, what I'm pinpointing is to a particular component, and that component is Q6027. Now Q6027 is a 2SA1266, and as you can see here, the reason for this fault is that the transistor, when it was removed from circuit, would test perfectly well on diode check mode. Nothing would indicate any issue at all, but as I now show, if you put it onto the component tester, and this is a transistor tester, you can see now that the gain of the transistor, and this is a typical generic signal transistor, it's very low. It's down to 20, HFE of gain of 20. And that's the issue. And the reason why this has happened is, and again, this can happen with any sort of semiconductor, typically when these sort of transistors go low in gain, it tends to mean that maybe that the transistor has been overdriven over a period of time, or there's depletion within the junctions which reduce the gain. Now unless you had a component tester, you wouldn't be able to identify this, and all that you could do is maybe just do a block change out of the component and then replace it. And then here what I show is a comparison, so you can now see that identical transistor, which is the one which was installed to replace this one, and you can see that it has a normal gain value. Now, as part of the repair, I didn't just simply replace the 2SA1266 transistor, or Q6027. You can see that there are other types of this transistor within the DC offset circuit, so, and also its equivalent as well. So these transistors were removed and then tested, and then on the right channel what I also did was just to replace the equivalent of Q6027 just in case. And then at the lower part of what I'm showing you here on the schematic, what you can see is there are two presets. The one preset is for the right channel, and you can't see that because I've just sort of removed that part of the circuit. But what I am showing is the preset, which is V6003, and that preset is used to adjust the DC offset for that channel. Now, once the amplifier had been repaired, and I also show here the solder side of the board, it's always good practice just to make sure that you don't have, for example, any heat related dry joints on any of the power regulators, and just to have a look around the board. There were some, but nothing that would cause any major issue, but just as good practice just to make sure that that's okay. And then here on the schematic, you can see that if you need to adjust the DC offset, the way in which you will do that is that you have no speakers connected at all to the amplifier, and then you will then connect your meter across the speaker terminals, and then what you're doing here is you're adjusting it to as close to 0 millivolts as you can, and the tolerance according to the service manual is plus or minus 3 millivolts. Now remember, you can do an initial adjustment when the amplifier is powered up, but then leave it for about 15 to 20 minutes just to stabilize, and then go back then and make your adjustment. What you can find is, if maybe this is an amplifier which has never been serviced, you might find that some of these presets are slightly twitchy in operation. They could be slightly dirty, so just depower the amplifier, spray some deoxit in there or contact clean, and just work it backwards and forwards until it cleans the carbon track, and return it back to about the position that it was previously. Then put the power back onto the amplifier, and you should be able to adjust it a lot more smoothly. Now it's clean, and you're looking for overall stability. Now, when that manufacturers put these presets into circuit, normally they'll look for a nominal value of about midpoint on the adjustment, and you're sort of moving left to right of that. What you shouldn't be seeing, for example, is the presets where they're extreme ends, be it anti-clockwise or clockwise. If that is the case, then you need to do further investigation into the circuit to understand why that is. Here, the gain, of course, would have impacted that immediately, because really the transistor was no longer acting, you know, as a transistor in terms of amplification of voltage. It was no longer the case. So once the DC offset was then corrected, the next thing to do is to pay attention then to the bias. And the bias is very easy on this amplifier again, and you can see here that you have a test connector and only 2 of the pins are used, and you put your meter across there, and then what you're looking to do is to adjust the preset until you are reading a nominal value of 20 millivolts. So again, you may do an initial adjustment maybe to 18 millivolts, wait for the amplifier to stabilize, and then readjust. And there's nothing wrong that once you've adjusted the bias for the amplifier that you go back and then you can just recheck then the DC offset. But when you're doing bias adjustment and also DC offset, ensure no speakers connected, volume control at minimum, and then all your other user controls then at midpoint then, and you should be able to adjust the amplifier back to normal factory settings. What you may find, and that was the case with this amplifier, that the bias was slightly high. It was in some cases up to about 43 millivolts, so that's quite high, but not unexpected. As with any amplifier, any electronic component, over time it will begin to drift as components age, and then you'll need to realign it and then to bring it back to normal. So the amplifier from a repair point of view was done. You know, we'd fixed the issue with the low gain transistor and carried out any sort of additional work. But the next thing is, during the test phase, it became apparent that and let's refer to it as the DAC module. So this is where you'll connect your optical input or your coaxial input When you looked at the optical input, the socket assembly was damaged, so you couldn't actually connect the lead to it. When I sort of looked from the rear, it was almost like there was like an entry flap which had sort of broken off and was inside, and you could even see a small spring clip, which I presume, you know, was holding onto the flap, but really, you know, badly damaged. Now, the way in which you remove this module is when you look from the back, you have a number of fixing screws, but then on the circuit board you have these standoff pillars, and how these work is that they are inserted into the main amp board, and then there's like spring plastic clips that just come out just to hold it in place. So if you're going to remove it, what I would advise here is you really need to remove the back panel and then lift up the amp board and then just squeeze the pillars just with the pliers and then extract it. What you don't want to do is just try and get them out of there, you know, using a screwdriver, because you're probably going to damage the board. Now, once the module is removed, what you can see is it's completely encased in metal, and then what I show here is the circuit board removed. So what you have to do very carefully, and again to avoid damage, you can use, for example, a plastic tool then just to prise off the top casing, and then when you look at the module, you'll see that there's a number of grounding tabs where the circuit board is soldered directly to the metal case, effectively providing like a Faraday shield or EMF type shield, and then to reduce the amount of electrical noise. And what I show is the module circuit board, and you can see there's quite a lot going on that board, and not on this amplifier but on other amplifiers that use these types of DAC units, on very early amplifiers, you know, often the electrolytic capacitors can sort of dry out. So if you're sort of recapping an amplifier which has maybe an early DAC board, if it's in one of these cases, just be sure to check those and make sure that those capacitors are good and don't also need replacing. Here it wasn't an issue because we understood that the socket was the issue. The next thing that I'm showing you again is the extraction from the manual. So what you can see here is the Toslink optical input socket, and this is the one that's damaged. So you can see here that you have the ground in and then also the VCC supply, and then it then connects the signal directly then to IC, in this case it is 301. Now the good news about this socket is it's readily available, and I've provided the part number there, so it's just JSR2124, and if you pop that into Google then it will come up and then it'll indicate that this is for the Marantz PM6005 optical stroke coaxial input module, and it's straightforward. You know, it's not a difficult thing to desolder from the board. So once the socket was you know, replaced, before you do the complete reassemble, of course make sure that you do the test. So here I can apply an optical input signal, and sure enough amplifier was working fine when you selected both the optical input and then also the coaxial input. So once that had been done and been verified, then I would do the reassemble, you know, to resolder the board back to the metal screen can, and then also then to replace the cover plate or the bottom cap plate, and then clip it back into the main board then, and then finally all you have to do is just secure the rear screw or the rear fixing screws then. So there you have it. So quite a sort of interesting repair, I would say. What I would also sort of mention is that unless you have, you know, this component tester, this is going to be a difficult fault to try and diagnose. Okay, you know that there's an issue, of course, with the DC offset adjustment, so you can focus in on that area of the circuit. But if you don't have a component tester, all that I can recommend that you do is to go and replace, you know, those signal transistors in that area. Now the signal transistor is no longer manufactured, so you can purchase a genuine original, but you would need to source them. For me, I have them in stock. Or alternatively, you can fit an equivalent where the gain is approximately the same and then operating parameters are the same, and that would be sufficient. You know, it's not sort of working hard in that circuit as such. And then just to close off with regard to, you know, the discussion about sort of DC offset, just to sort of clarify when we talk about DC offset. On very early amplifiers which didn't have a speaker protection relay or like any form of mute circuit, what happens is that when the amplifier is powered up, you'll hear what effectively is the charging up of the main power supply capacitors inside of the amplifier, and then this DC will appear momentarily on the rear speaker terminals. And what happens is that the DC current flows through the speaker coil, and then of course what will happen is it will deflect the speaker cone and then create a pressure change, which we interpret or we hear as a sound change. And remember, this DC offset, in that scenario, typically would be a positive voltage, and you hear this thud. As designs improved, what manufacturers then did is they fitted the speaker protection circuits, of course, to protect speakers, but what they were able to do is effectively mute the connection to the speakers for about 5 seconds, and then allowed the circuit capacitors to charge up, and then the relay would energize, connecting the speakers, and you wouldn't hear the noise. For these types of amplifiers as well, when you change the input, you may have such a circuit which will de-energize and re-energize the speaker protection relay. Here it doesn't, because it's using electronic switching and it doesn't incorporate that feature, but some do. Now, even if you have a DC offset which is not high enough to trip the protection circuit, you may still get on one or the other channel this annoyance where you hear a thud through the speaker because of the DC which is being applied. So in terms of amplifier design, the manufacturer will do their utmost to minimize the effects of DC offset, so you don't have that DC component. But some of these designs may well incorporate an electronic servo system which will automatically correct for any DC offset, or as in this amplifier, you have an electronic adjustment via a preset, and then some amplifiers it's just already set, so there aren't any sort of adjustments to make, and what they'll tend to do is to try and match the gain of these transistors to ensure that you don't have signal transistors in the appropriate part of the circuit, to minimize the overall DC offset component that could go into the speakers then. So the gain typically are matched, and that would be done during component selection prior then to manufacture them. So just a little bit more information for you, and as I said, an interesting repair, and hopefully if you come across this fault yourselves, you'll be able to focus in directly on that area circuit. And you may also find that it's actually the same transistor that I found in this amplifier on the left channel. So I really appreciate you stopping by and taking the time. And as always, if you require any help, guidance or assistance, by all means email audioamplifierservicing@aol.com, and I'll be quite happy to come back to you and provide any assistance or support that you may require. So until the next time, cheers, bye bye.